This next example will have us derive a formula for a population growth model, but one that's different and possibly more realistic. It says, suppose a population's growth rate is dependent on its size, but not simply in a directly proportional way. This is telling us that dn dt is not going to be as simple as just a constant times the population size. That's what that first sentence is saying. Not directly proportional to n. Let's look at the second sentence. Let's say that when a population is n equals 0, the per capita growth rate, and now we're talking about that little r, not dn dt. So the growth rate of the population is dn dt. The per capita growth rate is our little r. So we're told that the per capita growth rate is 2 individuals per year at that population size of n equals 0. And then the growth rate decreases linearly as the population increases, with a per capita growth rate of 0 individuals per year when n equals 1,000. This, first of all, is telling us that the per capita growth rate is not a constant. In fact, it's a function of the population size. By the way, in math, when we write something like r equals r of n, that's a shorthand way of saying r is a function of n. Little r is a function of capital N. Now that wouldn't help us too much, but except that there's a key word in here that tells us what kind of function it is. Can you spot the word that tells us what kind of function we have? It's this word linearly. That tells us that r is a linear function of n. All I need to get the equation for that is 2 points on the line, and they've given us 2 points. They've told us that when n is 0, little r is 2. In other words, 0, 2 is a point on the line. And they also tell us that when n is 1,000, r is 0. So in other words, the point 1,000, 0 would be on the line. To write the equation of a line, we need the slope. So rise over run. It's going to be 2 minus 0, that's our rise, over 0 minus 1,000, that's our run. So I have 2 over negative 1,000, which is the same thing as negative 1 over 500. We can use our familiar y equals mx plus b formula, although our variables will be actually r equals mn plus b. And we actually know what b is because the point 0.02 would be the intercept on the vertical axis. So I can say that r is slope 1 over negative 1 over 500 times n plus 2. By the way, in case you get mixed up about which letter is playing the role of x and which letter is playing the role of y in our familiar y equals mx plus b, just remember that r depends on n. just like in our old familiar y equals mx plus b, y depends on x. So we have the dependent variable by itself on the left side of the equal sign, and the independent variable is over in the formula. Okay, now we'll still use the model that the rate of change of population growth is per capita growth rate times n. It's just that now our little r, the per capita growth rate, is not a constant. We've got a whole formula for it that we just derived. So sticking with that model, but using our new and different type of r, we have dn dt equals minus 1 over 500n plus 2, because that's what r is, and then times n. This type of growth model is called logistic growth. We don't know how to solve this type of differential equation yet, but I'll just let you know basically what a solution curve would look like. It starts out looking a lot like an exponential growth curve, but then it levels off. And there will be some population that it can't get above due to some kinds of constraint in the environment. This level of population is called the carrying capacity of the environment. Let's see, and I should label my vertical axis too. That's n, and the curve is n of t. So that's that unknown function that we don't know how to find yet. But it would look like this. And in this particular example, the carrying capacity, I forgot a y in capacity, the carrying capacity would be 1,000. Because remember, the problem said that the per capita growth rate r was 0 when the population size was 1,000. So at that point, the births are slowing down or deaths are going up, and the births and deaths balance each other out, and you have just a level population.